So here is product of a power rule, so multiplying. You will notice that this question was on the assignment that we've been working on. Um, and again, product means to multiply. Remember, product is the answer to a multiplication problem. So if we have the expression, and remember, pause the video, so this is the first time for you guys to watch a video and take notes from it. Or I think this is the first time. But anyways, whenever you do this, you always pause the video. I always have everything written out so you're not waiting for me to write it all down. But pause the video, write everything down, and then after you're done writing everything down, then start playing the video again. So again, stop the video, write all of that down, and then yeah. So expanded form. So if we have 0.8 to the third, just like if we had 8 to the third, if you have 0.8 to the third, that means you have 3.8. So 0.8 times 0.8 times 0.8. That's this information. But what I kept seeing on the assignment is people would just put that, rewrite that as their answer. But you have to remember that there's also a times 0.8 at the end. This 3 just accounts for this. So there's 3 from that, and then there's 1 from the 0.8 that's multiplying. So remember, when we write the equivalent expression, which just means the simplified expression, it represents the same information, it's just written simplified. So when you look at this now, we actually have 1, 2, 3, 4, 0.8. So I could write it as 0.8 to the fourth. That does not look really purple, but I'll try a different one in just a second. So 0.8 to the fourth is how you could write all of this. Notice we don't actually multiply any of this stuff out. We're just simplifying it and saying you could write it as a single 0.8, and there were 4 of them multiplying out. Okay, now let's do this one. Okay, we have a 5, so we have 5. Then we have 4 5s, so 1, 2, 3, 4. And then we have 3 5s. 1, 2, 3. So then if you want to write it as a single 5, we could write it as 5 to the 1, 2, 3, 4, 5, 6, 7, 8. 8th power. If you were just trying to go based on rules and not actually have to expand this out, notice we have 4 and 3, but we said 8. So you have to think about this as an invisible 1 or an implied 1, because if there's just a 5, we know that there's just 1 5 multiplying there. So it would be 5 to the 8th power. The video keeps cutting out, so I'm going to stop it real quick and then start a new one. So don't be freaked out. Okay, here we go again. So now let's look at this next one. So we have 2x times 4x to the 5th. Now, there is a difference between 4x to the 5th and 4x to the 5th. Notice this 5 is outside of the parentheses, so that would be like saying both parts have the 5. This one, since it's 4x to the 5th and just the 5 is next to the x, not around the whole parentheses, there's actually only 5 x's, not 5 4's. So a lot of people get mixed up by that. You could also think of it as 4 times x to the 5th. Remember, when you have a number and a variable right next to each other like that, you can always just put a multiplication between them because that's what is the implied operation. So I could do it there too. So I have 2 times x Then I have times, you can't really see that that's orange, times 4, and then I have x to the 5th. So 1, 2, 3, 4, 5. So this information is right there, and that information is right there. Now when you do this, you want to write the numbers together and then the variables. So, and it's always numbers first. So then if I have 2 times 4, 2 times 4 equals 8. So it would be 8. And then I have 1, 2, 3, 4, 5, 6 x's. So x to the 6th. Okay, the next one we have 7xy times 2x squared. Again, I'm going to write multiplication between all those. So it'd be 7 times x times y times 2 times x squared, which would be x times x. Combine the numbers, 7 times 2. 7 times 2 equals 14. Now this one's a little bit new because there's an x and a y. There's 2 letters. So if we have 1x here and 2x is there, we don't talk about the y yet. We're just saying how many x's are multiplying. Just like we did up here, we said how many 5s were multiplying. Now we're going to say how many x's. So you would say x to the 3rd. And then there's only one y, so we're going to write just y. You could put the 1 if you wanted, but again, if you don't put a number here, it's like saying that, or it's not like, it's saying that there's just 1. And just a side note, you always put them in alphabetical order, so x comes alphabetically before y, so that's why I would write the x's first, typically. Okay. Now we have -3 squared, so I'm going to write -3 times -3. Then I have x, so x. Again, that cube was just with the y, so I would write y, y, y. And then I have times 1x. Okay, look at the numbers first. So there's still just 2 -3's. Then I have 2 x's, so I could write it as x squared. And then I have 1, 2, 3 y's, so I could write it as y cubed. Now, in some cases, they want you to multiply this out. For what we've been doing, we've just been leaving it as -3 squared or -3 to the 8th power, just because you guys don't have calculators to be able to type all of those in. Okay, sorry, I'm having to record from my iPad because the document camera stopped working. So if we look at this one, and again, pause it until you get the table all written down. But if you look, this is again a problem from the assignment that a lot of people missed. So if we have 11 divided by 11 to the 5th, so just having an 11 on top means there's just an 11 on top, divided by, if we have 11 to the 5th, I would write it out 1, 2, 3, 4, 5 times. Probably all moving and shaking, hopefully. Oh. So then we can again cancel one from the top, one from the bottom, which would just leave us with the 1 on top, or times 1, because remember, times 1 doesn't change anything. That's pretty much just a placeholder. So we're left with 4 11s on bottom. So I would write it as 11 to the 4th, because there are 4 of them on bottom. And then we don't have anything on top. So remember, you just need to leave a placeholder there to show that there is nothing there, but this 11 to the 4th needs to be in the denominator. If you think about our rules, this has an exponent of 1, so you could say 1 minus 5, and remember you have to do top divided by bottom, first divided by the second, so 1 minus 5 would give you a -4, and think about what we were talking about where a -4 gives you a, sorry, I know it keeps shaking a bunch, but I'm having to hold it up. A 4 would make it go to the bottom if you think about talking about negatives. So now, if we have 0, 1, and I just want to show you why that gives you a -4. -1, -2, -3, -4. So if we're at 1, and we need to subtract 5, so 1, 2, 3, 4, 5, we would be at -4, so that's why we got -4 there. Okay, the next one, if we have g to the 9th, so you could write out 9 g's, 1, 2, 3, 4, 5, 6, 7, 8, 9, divided by g to the 15th, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then you can cancel out. So we can cancel 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can cancel 9, and this is how many we're left with. 1, 2, 3, 4, 5, 6. Again, that's 6 in the denominator. So I would have to put g to the 6th in the denominator, and then I have to do that placeholder. Since all of those canceled out, we'd just be left with a 1 up there. So it would be 1 times g to the 6th. So 1 times g, or 1 divided by g to the 6th, I'm sorry. Now this is definitely one of those cases where it's easier if you just use the rule. So if I did the same thing as I did here, 9, not a g, sorry, 9 minus 15. So think about 9 minus 15. The negative is in front of the 15. So 9 minus 15 would be -6. And remember, a -6 would make it be in the bottom. On the assignment, I also took the negative exponent, but we usually don't write negative exponents. Okay, let's do this next one. Now we have x squared. Oops, I don't know why I'm just rewriting it out. So we have x squared. So, right, expand it out. So x times x. Then we have y cubed. So 1, 2, 3 over x y to the 4th. So 1, 2, 3, 4. Now, just like when we did these ones, the x and the y are separate. You talk about them separately. We're going to do the same thing here. So cancel an x and an x on bottom from top to bottom. Then you can cancel sets of y's. And I like to circle what's left so that I can easily see it. So we have an x on top and a y on bottom. So we would just write x, because that's the only thing that's left on top. And then the only thing left on bottom is a y. So then you would have your answer as x over y. Okay, last one. If we have numbers, now think about numbers. If I have 4 halves, 4 divided by 2, 4 divided by 2 is 2, not 1/2. So if I have $4 and break it between 2 people, each person would get $2. So if I have so $2, And notice it's not 1/2. If it would have been the other way where I had $2 broken between 4 people, then I would have had 1/2 and I would have put 1/2. But since the larger number's on top, the number has to be on top. Then we have an X, we have Y, Y, and then we have 3 Y's on bottom. Again, cancel, cancel. The only thing left on top is a 2X, and the only thing left on bottom is a Y. So it'd be 2XY. It's just a coincidence that the X stayed on top here and the Y was on bottom. That doesn't always have to be the case. It just depends on where everything is left.